solving question 11, which says to find the variables of each figure. In this case, we are solving for x. This trapezoid we can tell is an isosceles trapezoid because of the two tick marks on the slanted sides. So meaning that this side to the right equals 13 equals this side to the left. So we can just write to fill in that this equals 13. Now we can find x by finding the bottom side. So right now let's solve for the bottom, to the base of the small triangle. And we can do this by looking at the trapezoid. Because the middle is a rectangle, the bottom piece of the rectangle is equal to the top base, which is 24. So we can find this by getting the difference of 34 and 24 to find the triangle base. So we'll do that now. 34 minus 24 equals 10. So we have our bottom equals to 10. And now what we do here, since the entire bottom of the base is 34, because the trapezoid is perfectly symmetrical, we have to split the 10 evenly between the two outer triangles. So 10 divided by 2 equals 5. So actually this is like 10. This would equal 5 and this would equal 5. And now what we can do here is solve using the Pythagorean theorem. So this 5 would be the short end. So we need 5 squared plus x squared, which is what we're solving for, equals to 13 squared. And we are using this because the Pythagorean theorem is a squared plus b squared is equal to c squared. That is what we use. Okay. And so if we solve this, first we're going to do 5 squared. 5 times 5 is 25 plus x squared is equal to 13 squared. Okay, and if we continue on, 13 squared is, if I type in the calculator, 13 squared is 169. So what you want to do is, you want to isolate, get the x squared by itself. So you do that by subtracting 25 on both sides. Cross that out. X squared is equal to 44. And now what you want to do is square root to get rid of this exponent. You don't want that. You want the x to be completely by itself. So x equals 12. And this would be your final answer. X equal to 12. That is our problem. Okay, for our next problem, we are doing a problem from chapter 7, and it's question 14 that says to find the value of x. So the bottom right side over here, the x. So, because of the arrows over here, we can tell that these lines are parallel. So when the lines are parallel like this, you can cut across two lines, and they are perfectly proportionate. And so this is going to help us find our x, because we will be doing proportions. Top left divided by bottom left is equal to top right divided by bottom right. And so this is basically what we will be following. So let's see that right now. Let's plug them in. 8 from the top is divided by 12 is equal to 6 divided by our portion, what's missing, x. So you just cross multiply them like this. So 8 times x is 8x is equal to 12 times 6, which is 72. And since 8x you're technically multiplying, you want to divide 8 on both sides to cancel that out. So x is equal to
9. That is our answer.
Question we are solving from chapter 8, which is question number 4. And it says to find the value of x and express your answer in simplest radical form. Okay. So when we first look at this triangle, we can tell that it is a right triangle because of the 90 degrees over there. And we can also see that there is a
bottom right is equal to 45 degrees.
And since we know that this is 90, this is 45, we can infer that this is a 45, 45, 90 triangle.
Because it's a right triangle, and a right triangle equals to 180.
Okay, so to solve for the bottom formula, and it is hypotenuse is equal to leg times square root of 2. And so all we have to do is plug in our numbers. We know our hypotenuse, which is 26, is equal to x times square root of 2. And so we can get x by itself by dividing both sides by the square root of 2. So we can go right now, divide square root of 2, square root of 2. So we cancel this out. 26 divided by square root of 2. What we want to do is rationalize our denominator. And so we do this by putting 26 divided by square root of 2. We put this times on the top and bottom.
So square root 2 times square root 2 is equal to 2. And so we get 26 square root of 2. And what we want to do is look at the 26 and the 2. 26 divided by 2 is equal to 13 square root 2. And so that is our answer. Thank you.
The next problem is from chapter 10, and it is question 6, and it says to find the area of each polygon and round your answer to the nearest tenth. So, looking at this polygon, we can tell that it is a pentagon. And what we want to do first is look for the central area.
And we do this by dividing 360, because the whole entire thing is 360. And we just divide that by how many sides there is. Since it's a pentagon, we have 1, 2, 3, 4, 5. 5 sides. 360 divided by 5 is 72. So this is the central area. And now what we want to do next is find the apothem, which would be this line right over here. And so we do that by using SOHCAHTOA. So when finding the apothem, I like to split each section into these little triangles. So we can use this triangle to find for the height of the apothem. So we put our triangle like this. We have our 8, and so we're looking for x. And because this is our central angle, what we want to do is divide, because this entire thing is our central area angle. So what we want to do is divide by 2. 72 divided by 2 is 36. So that is what this is, and that is what this is at the top. And so what we want to do is look for the base of the triangle and the height. Right now, first we can look for the base of the triangle, so this one. And so we'll be solving for this using SOHCAHTOA. So from the 36% perspective, the x is the opposite and the 8 is the hypotenuse. And so that falls under sin. So we put in sin 36 degrees is equal to your opposite, which is x, divided by 8. You multiply 8 on both sides so we can isolate the x. And x equals to
4.7. So this side right here is equal to 4.7.
And since this is 1/2, since this is only the half of this triangle, this would equal the same thing.
So this entire side is equal to 9.4 inches. Okay.
Next, what we want to do is find the apothem, or the height. And so we can do that by using SOHCAHTOA again.
But this time, we're looking for different things. So this is going to be our x. So this is going to be our x. And we're looking at the perspective. We are going to use 36 angle. And from this perspective, we have h and a, because we have x as our adjacent and 8 as our hypotenuse. And so we'll be using cos.
So we fill it in again. Cos 36 degrees is equal to adjacent over hypotenuse, which is x over 8.
Multiply by 8 again. So x is equal to 6.47. And that is our apothem.
And so next what we want to do is find the total area. And so what we do is,
the formula for the area of apothem is 1.5 AP. A standing for apothem and P standing for the perimeter.
so to find the perimeter, all we have to do is multiply the length of the sides by all of the sides put together. So our perimeter
is equal to 9.4 times the number of sides, 5. That would equal to 47. So that
is our perimeter, and all we have to do, we have all of our factors. We just need to plug it in.
So area equals 1.5 A, which is 6.47, times our perimeter, 47.
152.05. And that is our answer.
So this is our last question. It is 13 from chapter 11, and it says to find the surface area and volume of each figure and round to the nearest tenth. Okay, so already looking at this, it is a cone, and there are 2 specific formulas that we need to solve this. So let's write them down. Surface area of a cone is equal to pi r squared plus pi r h stands for our height. If we plug this in, we use surface area is equal to pi. Okay, let's find our radius first. So it says, so this is the diameter, and to find the radius, we want half of this. And so the total is 8, so what we want to do is divide by 2, and 8 divided by 2 is 4. So we plug in 4 squared plus pi r again, which is 4, times height, which is 8. Okay, let's solve the left side first. For this problem, I'll be leaving it in terms of pi, just because that's what we always do. 4, let's look at this, 4 squared is equal to 16. 16 pi plus 4 times 8, which is 32. 32 pi. And if we add these together, we get surface area is equal to 48 pi inches squared. And that is the first half of our problem. Next thing we want to do is look for our volume. And so the volume of a cone, there is also a specific formula, and that formula is 1/3 pi r height. And so this, the 8 is not the height that we need. We are looking for the actual height, not the, we don't need the slant height. So what we want to do is solve for this, our x, using the Pythagorean theorem. So we can basically look at it like this. So we have our radius right here at the bottom, which is 4, and our slant height right here, which is 8. And so we'd be using the Pythagorean theorem, a squared plus b squared equals c squared. So our a would be 4 squared plus b squared is equal to 8 squared. Okay, so what we want to do is solve 4 squared is 16 plus b squared is equal to 8 squared, which is, look at that, 64. If we subtract 16 by 16, 64 minus 16 is 48. So we have b squared is equal to 48. And now what we want to do is get rid of this exponent, this square, by square rooting both sides. So b is equal to 6.93, about 6.93. So that is our slant height. Now we can actually solve for the volume. So v is equal to 1/3 pi our r, which is 4, and our new height, which is 6.93. Oh, sorry, I forgot to add a squared in the formula. So we put this into our calculator. We have 4 squared, which is equal to 16 times 6.93. That is 110.88, and we just divide that by 3, and we get 36.96 pi inches cubed. And that is our answer. Thank you.